So do you remember how back in week 6, or back in chapter 6, I don't remember if it was week 6, but about week 7, we still learned about the sampling distributions, and one was the normal approximation for the binomial theorem. And so what you do with hypothesis testing is, and then what the thing is, you had to think about how sampling distributions behave. That's where I was going with that. Just a minute, let me pause this and pull something else up. So remember, what we're looking at is, does it matter the shape of that parent population as long as you have certain sufficient conditions you can meet? And unfortunately, this applet doesn't go up to size 30. But what'll happen is when you draw a sample that's sufficiently large enough, let's see, let's animate this. See, it's going to pull 25 individuals out of that population, which is right skewed. Calculate the average, calculate the mean, and then it plots it on that next graph down. Okay, and then I can do this many times. I don't want to extend this, but if we do it 5 times, here's 5 results. Doesn't look very normal to me. Let's do 100,000 results. Well, that looks relatively normal to me, close enough to call it. So that is what a sampling distribution is. And then how do we apply this to hypothesis testing, significance testing? Well, if we were to get a sample, so we know what we're saying, we set a level of confidence or a level of significance. And if you think about the rejection region method, if your results out beyond that rejection region, say, yeah, that's far enough away from that hypothesized middle that something's going on, that the old mean, like what are they saying for this sample? For this population, they're saying the mean is 10.74, and we know that, not 95. So let's say we're going with a 5%. Let's say we're going with a 5% level of significance. That would mean there's a 5% chance that we're going to miss the population, whatever parameter is outside that range, or we could be making a mistake, I guess. That's like a type 1 error, but I'm getting confusing. So this is how things normally behave. If we get a sample result that's out beyond that, we can say, yeah, it doesn't look like that old sample result, hypothesized center is still holding. So if we look at, where's my book here? Come on, let's clear that. This one about speeding, because this is exactly what somebody asked me in the forum. He's claiming that most cars are going more than 5 miles an hour over the speed limit. So we're saying that the true center of this population is about 50%. And then, of course, we know if we did a confidence interval, there'd be some variation. But he's saying he's claiming that most are going more. So most would be more than 50%. So what his claim is way up here. He's saying that most cars, more than 50% of the cars, are speeding. So the null hypothesis says, no, that's not the case. It's just due to sampling variation. And the alternative hypothesis, the research hypothesis, what whoever I is claiming. Okay, so we run through that test here. Let's see, what do we got? We got p hat equals 29 out of 50, which is what, 58%. Well, 58% is bigger than 0.5, but is it far enough away? Is it far enough away? Let me get a different color ink. Is it far enough away from 0.5 to say that it's unusual, or is it within the acceptable range that we would expect to find? So, and we set that expected value because of the level of significance. So now let's go find Rossman chance. Theory-based applets one we've been using, and we got a proportion. We know 50 in our sample and 29 successes, people that were speeding in our accounts. And we're doing a test of significance. with a null hypothesis is 0.5, and we're trying to say it's more than that, a right-tailed test. So what that tells us, it gives us a test statistic of 1.13, and the p-value is 0.1289, which tells me, see that blue? I chose my colors well, didn't I? This blue is the test result. I mean, I don't know where it is, but it's inside that region that's within an acceptable variation, and it's just due to sampling variation. Okay, it's not an unusual result. So we do that because we know this is because the p-value is not smaller than 0.05, the level of significance. Okay, so that the question was, what does the null hypothesis tell us? Well, the null hypothesis tells us that nothing's unusual happening, that any sample result is falling within acceptable limits. Hopefully that helps.